So ATP, adenosine triphosphate, provides energy for muscle contraction. Sustained muscle contraction uses up a lot of this ATP energy, and the muscles have to store enough energy to be able to start contractions. So muscle fibers have to actually manufacture more ATP as it's needed. So there are two ways that it can do it. ATP and CP reserves, so adenosine triphosphate, can use creatine phosphate to make up more energy. So energy recharges ADP, adenosine diphosphate, to ATP using the enzyme creatine kinase. So creatine phosphate is used up, and then other mechanisms are needed to generate ATP. So creatine phosphate is the first level where ATP is generated within the muscle, but this is quickly exhausted. The other way that energy is used to produce ATP is by anaerobic glycolysis. So the first one is aerobic metabolism of fatty acids in the mitochondria, and the second one is anaerobic glycolysis in the cytoplasm. So glycolysis is the primary energy source for peak muscular action, and it produces 2 adenosine triphosphate molecules per molecule of glucose, and it breaks down glucose from glycogen stored in skeletal muscle. So aerobic metabolism is the primary energy source for resting muscles, and it breaks down fatty acids. So you get 32 ATP molecules per glucose molecule. So it's very efficient. Energy use and the uptake of muscular activity. Skeletal muscles at rest metabolize fatty acids and store glycogen. During light activity, skeletal muscles generate ATP through aerobic breakdown of carbohydrates, lipids, and amino acids. However, during peak activity, energy is produced by anaerobic reactions that generate lactic acid as a byproduct. So here we have a diagram showing you a resting muscle. So it's not doing any work, it's not contracting, and it uses fatty acids that are catabolized or broken down, and it produces ATP for energy reserves. And that creatine phosphate and glycogen. During moderate activity, you've got glucose and fatty acids are catabolized or broken down, and ATP is produced to power the contractions. At peak activity, you've got most ATP is being used up through glycolysis with lactic acid as a byproduct. And the mitochondrial activity not shown now provides only about 1/3 of the ATP consumed. So lactic acid is produced, and that's when your muscles ache because a lot of lactic acid builds up. What elite athletes do is they often get into ice baths to help the dissipation of this lactic acid in the muscles so that their recovery is more rapid.